I'm Anil Kumar sharing with you basic skills which are very important for mathematics. Now this video, especially for my new subscribers, some of them are starting with the course on functions or pre-calculus. So working with radicals is one of the most important part. Let us try to review how to work with radicals. So I've taken 3 questions here that will give you very good foundation for your course on functions or pre-calculus. Question number 1 here is, write the following as mixed radicals. Now these are all radicals, square roots. Mixed means with a whole number and then the radical. To give you an idea, square root of 32 could be written as, you could write this as 16 times 2, and so 16 is 4 times 4, so I could write this as 4 square root 2. Now that is a mixed radical, right? So we have a radical part and a whole number part. That is how you have to write the other two. The next one, question number 2, is simplify all this. Now again, you have those radicals. First step is to write them as a mixed radical and then combine the like terms, correct? So that is the strategy. So we'll take up these questions one by one. And question number 3 is to rationalize denominator. So I've taken very simple examples here, and I think that should not make much difficulty, but that will help you to review or some things which you have forgotten. So when we rationalize denominator, in the first case, there's just 1 square root 3. So to rationalize this, we'll just multiply and divide by square root 3, correct? So dividing and multiplying by the same number doesn't really change it, but it removes the radical part from the denominator. That's the whole idea. So the answer will be 2 square root 3 over 3, right? So we get 2 square root 3 over 3 as your answer. Simple as that. But when you're working with these, in that case, you have to remember to multiply and divide by conjugates. So you could use conjugates. So some of you could just pause the video, answer these questions, and then look into my suggestions. And now, let us take their solutions one by one in detail so that if it is new topic for you, even then you can understand. So question number 1, once again, we have to write with mixed radicals. First one I showed you. So basically what you do is, we look for numbers which are perfect squares. So 16 is a good number to look for, correct? 16 times 2 is 32. Now, how do we get 4 out? We do 4 times 4, that is 16. And now since we have 2 4s within the square root, I could write this as 4 square root 2, correct? So those are, more details about these steps. Now square root of 96. Now how do I get the mixed number radical from here? Now it could be very tricky. Sometimes you have very big numbers and you don't know what to multiply with. So what we could do here is we could do prime factorization, correct? You can divide by 4. 4 is a perfect square, right? So 4 times 2 is 8. So you get 16, 24. 24 is 4 times 6, correct? So that gives you an idea that I could split it like this. So I could write square root of 96 as square root of 4 times 4 times 6. Now we have 2 4s. We'll take one of them outside, and square root 6 you can't do much. Since the factors of square root 6 are 1, 2, 3 and 6, and none of them is a perfect square. So we are always looking for perfect squares. So the idea here is to write in factors. So basically write factors with perfect squares. Then you get them outside and get it as a mixed radical. That is the idea, right? Now here we have a very big number, 384. Now for 384, how could you do? Well, again, we could factor it. We can divide both by 4, since the last 2 numbers can be divided by 4. So 4 times 9 is 36. So we get 24. So that is 96. So 96 times 4. And we have already worked out that 96 basically is 2 4s and a 6, correct? So I took a related example so that you understand the concept and we move forward quickly. So what we have here is 384, which could be written as 1, 2, 3 fours, right? 1, 2, 3 fours. And now there is something very interesting. The fourth 4, if you see, we could actually write 6 as 2 and 3, but since we have 4, we could take out 2 out of it. Anyway, we will not bother much. So there's not much gain anyway. So these 3 fours, and we have a 6 here, right? So 6 cannot be simplified, but these 3 fours will give 2, 2, 2 outside. So get 2 for this square root, 2 for the other square root, 2 for the third square root. Do you get the idea? And square root 6, and that gives you 8 square root 6. So does it help? So that is how we could actually get as far as the number is concerned. Now, let us look into the other part, which is the variable. Now we have y cube. So y cube means we have y, y, and y. So basically, I could take one y out of these two outside. Do you see that? And one remain inside. So I'll have one y here and one y there. Correct? Now let us look into the third term, which is x to the power of 4, right? So the x to the power of 4 is also there. So that means we have, think like this, we have square of x square. So I could take out x square outside. So let me write x square here, right? So I could take out x square outside. So half of 4, that means 4 divided by 2, which is 2. So that becomes the power, correct? So what we really get here is 8y x square square root of y. So that is your answer for the given question. Perfect. So that is how you're going to do it. So I hope the things are very clear. When it is the numbers, you can do something like this. And when it is these powers, then remember this, that a to the power of m square root will be equals to a to the power of m divided by 2. That is the meaning. So we divided 4 by 2 to get square. And in case of 3 by 2, it's 1.5. So 1 came out and the half portion remained inside. You could see it like that. Does it make sense to you? Right? So that's what it is. Now let's move on and take up these questions. So these are all numbers. 8, 50, and 18 are within square root. So we are looking for the factors which are perfect squares. So 4 times 2 is 8, right? Minus. This is 25 times 2, and this one is 9 times 2, right? So purposely I've taken with something in common. 4 means that I could now write this as 5 times. 4 could be taken out as 2. It's 2 square, right? So that is what. Now this dot means multiplication, correct? So this is 5 square root 2 plus this is 3, right? 3 square. So it is 2 times 3 within square root 2. Now this dot is multiplication. What I'm trying to say here, this is square root of 2 with 10, right? So it is 5 square root of 2, and here is 6 square root of 2. Now all these are square root terms. So we could add, think like 10 apples minus 5 apples, add 6 apples, correct? So when you take away 5 apples, you get 5, and 5 and 6 is 11. So you get your answer as 11. Let me write 11 square root 2, right? 11 apples. So does it make sense to you? So that is how you could do such a question. Okay, so what we get here is 11 square root 2. Next one here is similar, but I'd like you now to pause the video, answer this particular question, and then look into my suggestions, correct? So 12 could be written as 4 times 3, right? 4 times 3 is 12. Why 4? Because 4 is 2 square. 9 times 5, right? 9 is 3 square. And 4 times 5, 4 is 2 square. That is why we take 4. And 75 could be written as 25 times 3. 25 is 5 square. So we could write this as 4 square is 2 square root 3 minus 3 square root 5 plus 2 square root 5 plus 2 times 5 times square root 3. Now, you have square root 3 and square root 3 terms. They can be combined. These two could be combined. And these two could be combined, right? So, think like apples and oranges. So, 10, so this is 10 square root 3, and this is also 10 square root 3. So I'll write this as 20 square root 3 here, okay? And when I combine these two, then it is minus square root of 5. Does make sense to you? So that is how you should be doing it. Perfect. So I hope all this is absolutely clear. So let's take the rest now. Number 2c, simplify 3 times square root 2 within bracket 2 square root 6 minus 10. So let me rewrite this question. Right? So we have 3 square root 2 and within brackets is 2 square root 6 minus square root of 10. So we'll apply the distributive property, right? So we'll apply the distributive property. Which really means that I need to multiply this with both. Okay, so this is equal to 3 square root 2 times 2 square root 6. So dot is times, okay? So 3 square root 2 times square root of 10. So when you multiply, so the numbers get multiplied with the numbers and the thing within the radical gets multiplied with that. So that is how we do it. So 3 times 2 is 6 and within square root 2 times 6 we get 12 minus. Here it is just 1, so it is 3, but within square root you get 20. And now it is the same process as we did earlier. We are looking for factors of 12 in which one of them should be at least a perfect square. 4 times 3. And here we get 4 times 5. Since you know that 4 is 2 square, right? So 4 is equals to 2 square. We can now write this as 6 times 2 square root 3 minus 3 times 2 square root of 5. And that is 12 square root of 3 minus 6 square root of 5. Now these are different terms, so they cannot be combined, but that becomes your solution. Perfect. So here what you get is 12 square root 3 minus 6 square root 5. Is that okay? Perfect. So now as an exercise what you can do is, just to practice, you could take up an example which is 2 square root 3 times 3 square root 5 minus 5 square root 18. Okay, so let this be your question. So simplify this one. Let's move on, take the next question, which is on rationalization. So rationalization basically means get rid of radical from denominator. So basically we want to get rid of radical from denominator. And it's a good practice never to write a solution using radical in the denominator. So if you have 2 over square root 3, what you need to do is, as I said earlier, rationalize. So we'll just multiply and divide by square root 3. So we get 2 times square root 3 here. And when you multiply square root 3 with square root 3, you get 3. So that is what it is. So it is equivalent to 2 square root 3 over 3. You get an idea, correct? So as an exercise, what you can do is, you can now rationalize 3 over square root 2. What is this equal to, correct? So let's take up the other two. So here we'll multiply by the conjugates. So in such cases, we actually multiply by, so we use conjugates. Now what are conjugates? So if I have a plus, let me write a square root a plus square root of b, then the conjugate will be square root a minus square root b, right? So the idea is, when you have a plus b times a minus b multiplied, you get a square minus b square, so you get rid of the square root. So that's the whole idea. So the idea here is that if I do square root of a plus square root of b and multiply that with square root of a minus square root of b, what I get? I get square root of a square minus square root of b square, which is a minus b. So I got rid of the square root terms. So that is our concept, okay? So using this concept, I'll do one of them. So I'll just do part B and C is for you to practice. Is it okay? So let's do this. So in part B, we have 2 minus square root of 3 over 3 square root 5 minus square root 3. Now what is the conjugate of this? We have to change this sign, right? So we get 3 square root of 5 plus square root of 3 over 3 square root of 5 plus square root of 3. Now see, why did we do that? We are rationalizing the denominator, right? So we took conjugate of the denominator. You get the idea? Sometimes the question could be rationalize the numerator. Then you'll multiply by 2 plus square root 3 and 2 plus square root 3, right, over that. Now this is just 1, so it doesn't really change anything over here, right? So that is what it is. Now, once you do that, then is simple distributive property, which we learned in previous example. So we'll actually do the numerator part first. Okay, so we'll multiply 2 by this number, both of them, right? So we get 2 times 3 as 6 square root of 5, and then with here we get 2 times square root of 3. With minus, the signs will change to minus, and that radical gets multiplied by the radical inside, right? So 5 times 3 is 15. So we get 3 square root of 15, and on this side minus square root 3 is just 3, correct? Denominator, using this property, we get 3 square root 5 whole square minus square root of 3 whole square. You get an idea, correct? So that is what it is. Now you can combine the like terms. Now in this, if you see the numerator, there are no like terms. Square root 5, square root 3, square root 15 and 3. None of them is a like term. So just leave it as such. And in the denominator, we could simplify, right? So in the denominator, we could simplify. How? Simply because this square will be, what will be? 3 square is 9 and times 5 minus 3, that is square root 3 square, right? So it is 9 times 5, 45 minus 3. So the denominator will be 42, right? 45 minus 3. The numerator as such, any order you could write, right? So I'm not very particular about that order. Some books are. Okay, so anyway, we'll just keep it like this. So that becomes your solution. I hope that is absolutely clear. I would like you to apply the same strategy and do part C, which is simpler since we do not have to do the distributive property in the numerator, right? So straight away it'd be 2 square root 3 times 3 square root 6 plus 5 times square root 3, and in the denominator will be difference of their squares. Is that okay? So once you're done, and if you have questions, do just post your questions. But I hope that helps you to understand this basic skills of working with radicals, which will be very important for anybody doing pre-calculus course. I hope you understand it. Feel free to write your comments and share your views, and you can share my videos with your friends. Thanks for watching and all the best.